Welcome. Today's lesson, we are starting trigonometry. How exciting. So, trigonometry talks about the trigonometric ratios, which you may have heard of, sine, cosine, and tangent. So before we define what those are, we got to define a few other things. So first thing I want to say is when we talk about trigonometry, we are talking about right triangles only, okay? So all the triangles we're talking about are right triangles. So first definition, we need to talk about opposite side and adjacent side. So opposite side to a non-right angle in a right triangle is the side that does not touch that angle. All right, so if I have a right triangle and I am talking about this angle here, the opposite side would be this side here. So this side is the opposite side. The adjacent side to a non-right angle in a right triangle is the non-hypotenuse side that creates the angle. All right, so if I still had that same picture, okay, I'm still interested in this angle here, the adjacent side is going to be this side right here, right? Because it's the side that helps create that angle that is not the hypotenuse. So remember, the hypotenuse is the longest side. It's the side across from the right angle. Okay, so we have opposite, adjacent, and hypotenuse are the three sides. And the opposite and the adjacent depend on which angle of interest you're talking about. So let's do an example. So for the triangle, state the following. The side opposite to angle A. So if angle A is my angle of interest, my hypotenuse is over here. The side opposite, remember, is the side that doesn't touch angle A. So my side opposite is going to be this side over here, which is segment BC. Then the side adjacent to angle A is the side that creates angle A. That's not the hypotenuse. We already have the hypotenuse, so the other side that creates it is going to be this side here, and that's side AB. Now, if I want to talk about the opposite and adjacent to angle C, those are going to actually switch because the opposite side, the side that doesn't touch angle C, is segment AB. And the side that does touch angle C, that's not the hypotenuse, is going to be side BC. Okay? So depending on which angle you talk about will determine which side is opposite and which side is adjacent. The hypotenuse is always the same no matter which angle of interest you have. All right, next, now we get to define our sine, cosine, and tangent ratio. So the sine ratio of an angle. So we say sine, and we put in our angle, is going to be the length of the opposite side over the length of the hypotenuse. Okay, so length of opposite side over length of a hypotenuse. Okay. And so we might write it as sine of the angle equals opposite over hypotenuse. Okay, our cosine, we abbreviate with COS. So our cosine of our angle is going to be the length of the adjacent side over the length of the hypotenuse. And the tangent, TAN, of an angle is going to be the length of the opposite side over the length of the adjacent side. So if I want a good way to help memorize these is something we call SOHCAHTOA. You may have heard of this before. So S-O-A, or S-O-H, excuse me, is S for sine, O for opposite, H for hypotenuse. Ka, or for cosine is adjacent over hypotenuse, and TOA is T is opposite over adjacent. Okay, so SOHCAHTOA can help you memorize those ratios. All right, so let's put them into practice. So here's our first example. Write the sine, cosine, and tangent ratios for angle J and for angle K. All right, so I need for sine, I need opposite and hypotenuse. If I look at this figure, I don't have the length of the hypotenuse yet. So I'm going to do some trig here, or not some trig, some good old Pythagorean theorem to find it. So I have 3 squared plus 7 squared equals my hypotenuse, which we're going to call C. C squared, so I have 9 plus 49 equals C squared. 58 equals C squared. Take the square root. So square root of 58 equals C. Okay. And that's my hypotenuse. It doesn't matter which angle of interest I have. So let's do angle J, and I'm going to color code these. So I'll do angle J in purple. So if this is my angle of interest, the side that doesn't touch it is 7. So that's the opposite side. The non-hypotenuse side that does touch it is 3. So that's the adjacent side. So the sine of angle J, so this is how you write it, just SIN, and then in parentheses you put your angle name, is going to be the length of the opposite side, 7, over square root of 58, which we have to go through and multiply by square root of 58 on the top and the bottom, and I can't reduce that. So I just get sine of angle J is equal to 7 root 58 over 58, okay? Cosine of angle J, now instead of the length of the opposite side on the numerator, I have the length of the adjacent side, which is 3, and my hypotenuse is square root of 58. So cosine of angle J equals 3 root 58 over 58. And then tangent, we abbreviate TAN, of angle J is going to be opposite over adjacent, so 7 over 3. All right, now let's take a look at K. So if K is my angle of interest, now what's going to happen is my adjacent's going to stay the same, but I am now going to have different opposite and adjacent sides. So the side opposite to angle K is going to be 3, and the side adjacent to angle K is going to be 7. So when I do the sine of angle K, I'm going to have the opposite side is 3. So I have 3 root 58 over 58. The cosine of angle K is going to be 7 over root 58, or 7 root 58 over 58. And then the tangent of angle K is going to be the opposite over adjacent, so 3 over 7. Okay, so they are all similar, but they're not quite the same. So let's talk about this. So our next question asks, what do you notice about the ratios in example B? Here, let me put some space here so we can look at this. So what do I notice about these? Well, the first thing I notice is that my tangents are reciprocals. Okay, so tangent of angle J and angle K are reciprocals. The other thing I notice is that the sine of angle K is the cosine of angle J, and the cosine of angle K is the sine of angle J. So then I notice that the sine and cosine ratios are swapped for angle J and angle K. And this, in fact, is true for all complementary angles, okay? Because if two angles are complementary, then they could be the two angles in a right triangle, the two non-right angles, okay? So these two facts are true for all complementary angles. And I'm sorry if you can hear my dog munching on a bone right now. They got a nice tasty treat, so they wouldn't be barking while I made this video. So sorry about that. I'm going to fix that word. Okay, great. Next, I have a little picture of a calculator here. So if you have your scientific calculator, your graphing calculator, get it out. We will be using that for this example. So next example says find the value of W to the nearest tenth. So in this example, we are given the angle measures and not all the side measures. All right, so if I want angle W, so what I'm going to do is I'm going to pick an angle of interest. It doesn't matter which angle you pick because we know all three angles. You need to pick one of the non-right angles. So I'm going to pick 57, okay? If you pick 33, that's great too. So if 57 is my angle of interest, I'm going to label my hypotenuse, my opposite side, and my adjacent side. So the two sides I have information about are the opposite side and the adjacent side, okay? And if I look at my trig functions, SOHCAHTOA, the trig ratio that uses opposite and adjacent is tangent, okay? So I'm going to use my tangent ratio. So the tangent of 57 degrees equals opposite over adjacent, so W over 2.5. So then in my calculator, I'm going to type tangent of 57. So tangent is this button right here. Okay, so I'm going to hit tangent, and then I'm going to hit 57. And when you do that, you're going to get, let me make sure my degree, yeah, okay. You should get 1.5398 so on and so forth. Okay, and that's W over 2.5. Then the next thing I'm going to do is I'm solving for W. So I'm going to multiply both sides by 2.5 so that it cancels. And now I'm going to multiply my answer there in my calculator. And I am going to get that 3.85 equals W. Oh, it says to the nearest tenth. Tenth means one decimal place. So it is just 3.8 equals W. Okay, so 3.8 equals W. All right, so that would be my answer there. If you did it using the 33, you would still be using tangent, but remember your tangent would be flipped. So you would have 2.5 over W, and you would still do the same thing, except instead of 57, you would have 33. All right, next. Ralphie is planning to build a grain bin with a radius of 15 feet. He reads that the recommended slant of the roof is 25 degrees. That's supposed to say wants the roof to overhang the edge of the bin by 1 foot. Okay, what should the length of X be? Give your answer in feet and inches. All right, so we are interested in this triangle here. Okay, so I'm just going to redraw it bigger. So essentially we have this, and we know that the radius of the bin is 15, and then it overhangs 1. So we know the length of this side here is 16 feet. And we want to figure this out if this is 25. So here is my angle of interest. So my angle of interest is this angle here, and I'm going to label all my sides. So hypotenuse, opposite, and then 16 is the adjacent. So I have information about the hypotenuse and the adjacent. So that means I'm going to use cosine. So I have the cosine of 25 degrees equals the adjacent 16 over the hypotenuse x. So the first thing I'm going to do is I'm going to multiply both sides by x to get rid of x in the denominator. There it goes. Okay. Now you're going to find the cosine of 25 degrees on your calculator. So hit the cosine button and then 25 and hit enter. And so now I have that x times, and cosine was 0.9063-ish. equals 16. And then I'm going to divide by that 0.9063. My dogs are so loud. I apologize. So then I want 16 divided by that. And oops, nope, that's not what I want. I want 16. I accidentally multiplied. 16 divided by cosine of 25 gives me x is going to be 17 point. Tell me how to round. Give your answer in feet and inches. Oh my goodness. Okay, so then we have 6, 5, 4, 0, 4, 6, 7. Okay, so we have 17 whole feet, and then we need to find how many inches this is. Okay, so there's 17 feet. And then if I want to find how many inches that is, so I'm going to say, okay, so if I have 0.654 feet times, I know 1 foot equals 12 inches. So times 12. So if I multiply that by 12, that is going to be 7.85 inches. So my final answer would be 17 feet and 7.85 inches, or 17 feet, 8 inches. Okay, if I want to round to the nearest inch. All right, great. Now I would like you to try your homework, which should not be as hard as this last example.